decimal operations and equations with decimals. Just like we have done before with addition and subtraction with whole numbers, we can do the same thing with decimals as long as we remember how to add and subtract decimals and how to multiply and divide decimals. So if we start out with adding decimals, well, when it comes to addition and subtraction or positive and negatives, we're still dealing the same way. In other words, if they're both negative, we can add them together. So in this case, we will have 2.9 and 6.5. Well, how do we do this? With addition and subtraction, we have to actually line up our decimal. We have to. So we are adding two negatives together. So 9 plus 5 is 14. 8, 9. And then I can just bring down my decimal and my sign whenever it comes to addition and subtraction in a decimal. Here we have a negative and a positive, so just like before when we had whole integers, we're going to subtract these two numbers. Minus 25.38. Again, I lined up my decimals. Since I have two decimals here and three here, I have to add a 0 in here to make up that spot. I put the bigger number on top. 4 minus 0 is 4. 3 minus 8 you can't do, so I borrow. 13 minus 8 is 5. 6 minus 3 is 3. Bring down our decimal. I can't subtract here. 12 minus 5 is 7. 3 minus 2 is 1. Our bigger number is positive here, so my answer has to be positive. So this will equal 17 and 354 thousandths. So that's addition and subtraction, very similar to what we've done before. You have to remember your decimals from 3rd grade, possibly 2nd grade. But other than that, you should be fine. So then multiplication, when it comes to multiplication, again, our signs act the same way. Two negatives make a positive, two positives make a positive and a negative make a negative. So same signs are positive, and negatives and opposite signs are negative. But how do we multiply these? So when we multiply them, you don't have to line up the decimals. What I'm going to say is let's go ahead and line up the decimals just so it stays cemented in our brain when it comes to addition and subtraction. We're trying to go back and forth. So 7 times 4 is 28. Carry the 2. 7 times 8 is 56 plus 2, so 58. 7 times 1 is 7 plus 5 is 12. Of course, we have our placeholders and our 3 zeros. So 8, add these together. 8, 2, 1. Now, the difference between this multiplication and addition is we actually have to count up how many decimal spots we have. We have 1 spot, 2 spots, so we should have 2 in our answer. We had a negative times a positive, so we're going to have a negative 12 and 88 hundredths. Try another one. I'm going to go ahead and line up my decimals. 5 times 5 is 25, 10, 11, 12. 45, 46, placeholder, 20, carry the 2, 8, 9, 10, carry the 1, 36, 37, add down, so we get 5, 2, 6, 11, and 4. Negative times negative is a positive. We have 1, 2, 3 decimal places, so we have to have 3 in our answer. So we'll start here and go 1, 2, 3. Remember, we always start on the right side and move to the left when we're finding our decimal position. So we have 41 and 625 thousandths. Division. Well, with division, we're just starting out with our first number in the division sentence inside and outside. I'm not going to worry about the positives and the negatives right now. Since we do have a decimal on the outside, I have to move it to the right until it becomes a whole number. And if I do it to the outside, I have to do it to the inside. I have 19. It can go not into 2, but into 29 one time. Subtract. So I get 0 and 1. Bring down the 0. My decimal's here, so I'm going to go ahead and bring it up. I should have done that earlier. 19 into 100. Well, I know that 20 can go into 100 5 times. So 19 times 5, let's start there. So that's 5 and 4, 9. 95, can't go any more, so that's perfect. I know 100 minus 95 is 5. bring down my 7. 19 into 57, I know that 20 can go into 60 3 times. So let's see if 19 is close here. 7 and 2 and 3, 4, 5, 57. That works out perfect. So I get a 3 here. Subtract, and I get 0. So now I have to decide on my sign. I have a negative divided by negative gives me a positive. So I get a positive 15 and 3/10. Again, we'll do division. Inside goes the first number. Outside goes the last number. I have a decimal on the outside, so I move my decimal one place to the right. One place to the right, bring it up. So now I have 33. Can it go into 1? No. Into 16? No. Into 168? It should. 168 is a lot bigger. But how many times is it going to go in? So 30 could go into 155 times. So let's start there because it would, let's see, 18 more, so that should be working. 5 times 3 is 15, 15, 16, so I get 165, pretty close. Subtract, and I get 3. Bring down my 3. 33 goes into 33 one time. Subtract, and I get 0. So my answer here is 5 1/10, but is it positive or negative? So a positive divided by negative, opposites. When opposites divide, we get a negative 5.1. Here we want to solve. The first thing I look at is I say, what's my letter? What's my variable? My variable is x. What is with my variable? It's the number 4 7/10. So what are they doing? They're adding. How do I get rid of addition? I do the opposite, so I subtract. So I'm going to subtract the number 4 7/10. If I do it to one side, I have to do it to the other. So I come over here, I find my constant, and I subtract 4 7/10 from it. So I get 0 over here. So x plus 0, or just x. Well, here, I can't subtract in this order, so I'm going to have to flip it around. I'll put 4.7 on top, 3.5 on the bottom. 7 minus 5 is 2. 4 minus 3 is 1. Bring down my decimal because it's addition and subtraction. We can just bring it down. But is it going to be a positive or a negative? 4.7 is definitely bigger than 3.5, so my answer will be a negative, so we take the bigger sign. Again, we come over here and we say, what is our variable? It's y. What's with the y? 6 and 91/100. What are they doing? They're subtracting. What's the opposite? Adding. So I'm going to add 6 and 91/100 to both sides. Again, we get 0 here. So you get y plus 0 is equal to, well, 6 and 91/100 and negative 2 and 26/100 means that I'm going to have to subtract these again. Again, line up my decimals. Interesting that my 6 is not showing up there. There we go. 1 cannot subtract 6, so I have to borrow. 11 minus 6 is 5. 8 minus 2 is 6. 6 minus 2 is 4. Bring down my decimal. 4 65/100. Is it positive or negative? Well, the 6 is the bigger number and it's positive, so I'm going to keep that sign. So I get y is equal to 4 65/100. Example 4. Multiplication. I started out the same way as I was starting out with addition and subtraction. I first asked myself, what's the variable? The variable here is m. What's with the m? It's a negative 6/10. Well, what's it doing? It's multiplying. So what's the opposite? It's dividing. So I'm going to divide. I'm going to divide by negative 6/10. So I take the negative with it here. So I divide by negative 6/10 on both sides. I'm left with 1m equals, well, 5.1 goes inside because it's on top. 6/10 goes outside. Again, I bring my decimal one place to the right so that we get 6 here. Bring my decimal up. 6 can go into 51 8 times, which is 48. Let's see, borrow. 11 minus 8 is 3. 4 minus 4 is 0. I need to go ahead and take this out completely. So I'm going to add a 0 here and bring it down. 6 can go into 35 times. 6 times 5 is 30, so subtract. And I end up with 8.5. The question now is it positive or negative? Two negatives. A negative divided by negative is a positive, so I get m is equal to 8 5/10. Over here, what's my letter? What's my variable? It's n. What's with the n? It's a -8. What are they doing? They're they're dividing. What's the opposite of dividing? It's multiplying. So I'm going to multiply by -8 on both sides. So I get 1n equals, multiply this, 1 and 75/100. 8 times 5 is 40. 8 times 7 is 56. Plus 4 was 60. 8 times 1 plus 6 gives me 14. I have 2 decimals here and none here, so I have 2 in my answer. So I get 14.00. Negative times a positive is a negative, so I end up with n is equal to 14. Negative, make sure I put that on there, -14. So example 5 goes back to our beginning hibernation paragraph here. It says, when a chipmunk hibernates, its heart rate decreases, its body temperature drops, and the chipmunk loses weight as its stored body fat is converted to energy. So example 5 asks, when a chipmunk hibernates, its weight decreases by about 31/100ths of a pound. So it decreases, it goes down, or it's negative. After hibernation, the chipmunk weighs about 35/100ths of a pound. Find the weight of a chipmunk before it hibernates. So we have weight before hibernation. We have the amount loss. The amount lost, and then this equals the weight after. So our weight to start with, we don't know, that's what we're looking for. The weight that we lost was 31/100ths, and the amount afterwards was 35/100ths. So now we can solve this. The opposite of subtracting 31/100ths would be to add 31/100ths. Do it to both sides. We get W plus this goes to 0 is equal to 6. So 66/100ths. So W is equal to 66/100ths of a pound. And make sure you put the units on here. I'm going to start counting it wrong. Page 105, we're doing 12 through 35. We have 7 8/10 plus -9 3/10. So we're adding a negative here. A positive and a negative are going to subtract. Borrow. 13 minus 8 is 5. Bring down my decimal. 8 minus 7 is 1. Which one's bigger, 7.8 or 9.3? It's 9.3. So my answer will be a -1 5/10.